Hey, HS1 students. On this short recording, I'm going to present solution of your quick test about forces. So let's focus. You can write a topic in your notebook, test, revision, or something like that. You have a blank copy of the test. It's still accessible in Google Classroom. So please maybe open it. I'm going also to present questions on the screen and write correct answers. Okay. When you will be ready, please turn video back and let's do this test. Okay. So. Exercise number 1 was related with the slope. The main is an object of mass 2 kilograms is placed on a slope of length of 12 meters and angle to horizontal 30 degrees. Slope is frictionless. Use g equals to 10 meters per second squared. You have to draw free body diagram. So diagram representing forces acting on the object. Okay, object experiences only two forces. If this is our slope, then object experiences two forces. The first force is gravitational force, which acts vertically down, and second force is force which acts normally to the surface of the slope. Okay, so gravitational force and normal reaction force. And of course, these two forces are not equal in length. Normal reaction force is less than gravitational force, okay, because both add together result in downward force, but the downward force is a resultant force of these two forces. So downward force is not part of free body diagram. You have to draw only this Fn and Fg, so this is correct answer, and Fn is shorter than Fg. Okay. The second question. Find downward force. In this case, you have to calculate. Okay, so you can use standard equation for downward force. So Fd is equal to mass times g times sine of the angle, mg sine. So this is 2 times 10 times sine of 30 degrees. If you use calculator, it results in 10 newtons, and 10 newtons is the answer. Okay. Third, find acceleration of the object. So it's also not challenging. In this case, you have to use second Newton's law of motion. Okay, acceleration in this case is resultant force, so downward force divided by mass. So you have to divide 10 by 2, which is 5 meters per second squared. Okay, this is your first exercise. Most of you like this exercise correct. Okay, exercise number 2. Up, up. Okay, and here. An object of mass 4 kilograms is placed in the slope which makes 45 degrees to the horizontal line. Friction coefficient is given. You have to create free body diagram, so similar question to the first one. Again, similar problem. This is our slope. Maybe a little bit like this because it makes 45 degrees. And in this case, object expresses three forces. It is gravitational force vertically downward, normal reaction force perpendicular to the slope shorter than gravitational force, and frictional force which acts oppositely to the direction of motion. Direction of motion is down, so frictional force acts along the slope up. Okay, second, find downward force. Okay, so similar problem to the previous one. We have to use standard equation for downward force. It is mass times gravitational acceleration times sine of the angle. Okay, so this is 4 times 10 times sine of 45 degrees, which is 28.3 newtons. Find frictional force. This is third question. Okay, frictional force of course, is normal reaction force. Wait again, find frictional force. I have to copy it and paste. Okay, frictional force is normal reaction force multiplied by friction coefficient. Okay, so force of friction coefficient times normal. So finally it is mu mg cosine of the angle, which is 0.2 times 4 times 10 times cosine of 45. Use calculator, and it is 5.7 of newtons. Okay, find resultant force. Okay, resultant force, of course, is a difference between force acting down along the slope and up. So resultant force is difference between downward and frictional. So difference between 28.3 and 5.7. So this is 22.6 of newtons. Okay, and last one, find acceleration of the object. Okay, acceleration of the object, easy, second Newton's law of motion. Acceleration of the object is a ratio between resultant force and mass. So this is 22.6 divided by 4, which results in around 5.7 meters per second squared. Remember about the units. Units at the end in the final answers are obligatory. So here we have exercise number 2 solved. Okay, and last exercise number 3. Exercise number 3. Probably your favorite, because most of you did this exercise correctly. Most of you, not all of you, most of you. Okay, so we have two masses, 2 kilograms and 3 kilograms are connected together by an extensible string, which is also connected with the pulley. Look on the picture. Okay, use g equals to 10 meters per second squared. You have to find acceleration of the system and tension of the string. Okay, so each mass experiences two forces. And we know that system accelerates clockwise. M2 falls down, M1 goes up. So mass number 1 experiences force of tension, Ft, and gravitational force, Fg1. And Fg1 is shorter than Ft because the resultant force acting on mass 1, so F1, must be directed up because mass 1 moves up, accelerates up. Mass 2 also experiences two forces, tension, which is the same as tension acting on mass M1, and gravitational force, which must be longer than tension, Fg2, because overall force, resultant force, acting on mass M2 must be directed down because mass 2 accelerates down. So we have two equations. First equation for F1, that F1 is a difference between Ft and Fg1, and F2 is a sum of Fg2 and is a difference between Fg2 and Ft. Okay, so remember that F1 is m1 times a and F2 is m2 times a. Acceleration is the same because these masses are connected by an extensible string. So we have m1 times a is equal tension minus m1g, because Fg1 of course is m1 times g, and Fg2 is of course m2 times g. And second equation, very similar, m2 times a is equal to m2 times g minus Ft. So we have simultaneous equation. Substitute data, m1 is 2, so 2a is equal to Ft minus 2 times g, which is equal to 10, and m2 is 3, so 3a is equal to 3 times g times 10 minus Ft. Calculator or manually. So if manually, then you can write equation for Ft by using first equation and substitute this to the second, obtaining 3a is equal to 30 minus the sum of 2a and 20, which is 3a equals 30 minus 2a minus 20. So finally 5a is equal to 10. So acceleration is equal to 2 meters per second squared. Okay, this number is of course 10. And also ft, we can use this equation. Ft is 2a, so 2 times 2 plus 20. 2 times 2 plus 20 is of course 24, so tension is equal to 24 of newtons. So acceleration is equal to 2 meters per second squared, and tension is equal 24 of newtons. Okay, I hope that now you understand the test. You can compare your solutions, which are also accessible to you, with my solutions. Remember, I subtracted points if you didn't write unit in final answer, if your arrows are not longer or shorter but equal. Okay, so you have marks. I can send you your marks, and here you have all solutions. So check your tests and compare your score with your technique. Okay, so thank you for watching. See you. Bye.